right, welcome back. What we're going to do is we're going to talk about how to solve, once again, another lesson on how to solve with factoring using the AC method. Um, this is just a method that I promote that will help you factor almost everything. So if you need like a cookie cutter, fast way of doing it, the book has a different way, but this is using what's known as the AC method. I have two other tutorials on how to do this, so I'm going to kind of just pick off and get started. So let's say we want to factor this. Now the AC method basically comes off the principle where you have a trinomial of a quadratic, all right, where you have ax squared plus bx plus c, all right, and we're going to use the AC method. Now I'm not saying you have to use this method for every single thing, but it can be used pretty much for any factoring, any trinomial expression, all right, quadratic trinomial expression. So right here, what we're going to do is we're going to take our coefficient next to the x squared, which is our a, and our c value. So right here is going to be 1 times 30, okay, 1 times 30, because 1 is actually the coefficient next to x squared. When we do that, what we have is 30. Now, from here, we're going to now take our b value, okay, our b value, all right, and our b value in this case is negative 11. So that means that I have to find factors of 30 that I can add together to equal negative 11. Now, since we have a negative 11, so we want to take the factors of this and ask equal negative 11. So once again, we have to add two negatives. So what we're going to do is let's start off right here. Now let's think of 30. Well, 30, we have 30, negative 30 times negative 1. So that'd be negative 30 plus negative 1, which would give us negative 31. That won't work. We can go next one is like 15. We have negative 15, all right, times negative 2. All right, negative 15 times negative 2 is going to be negative 15 plus negative 2. All right, and that's going to give us negative 17, or we need negative 11. That doesn't work. Let's try this one. We got negative, what is it? 15 was 3. We go negative 10, all right, times negative 3. So this would be negative 10 plus negative 3, which is actually negative 13. All right, that doesn't work. All right, let's go 4, 5. Let's try 5. All right, negative 6 times negative 5. That's going to give us 30, right? So we have negative 6 plus negative 5, which gives us, hey, there we go. We found it, negative 6 plus negative 5. So we're going to write this out. So we're going to have x squared. All right, these are our b values. So you're next to the x value here. So we have negative 6x. We're going to have negative 5x. And that's going to be plus 30. From here, we're going to group our two values. So we're going to use a little grouping here. All right, grouping. When we're grouping things, that means we're going to divide out. So what are the common two factors out of here? We're going to factor out an x. And so we have is x minus 6. Right here, I don't have a negative, so I'm going to factor out a negative 5. If I factor out a negative 5, what will happen is I'll have a positive x. That's good. One of the things we want to make sure that this equals each other. And then we're going to have negative 6. And once again, we find out that we have a common factor. And that's actually one of the factors we're going to use. So we're going to have negative, or x minus 6. We're going to factor that out. We're going to factor this and this. And then what we have left over is x is left over minus 5. And that, my friends, is what's going to equal x squared minus 11x plus 30. And there's our factor. Awesome, huh? Let's try this one. Whoops, this one's supposed to be z. I apologize. All right, we have z. Okay, going through the same process. I'll change my color because it's a different problem. A little green here. All right, we're going to use the AC method. So I'm going to take my AC. So AC, my A value is 1 in this case. So 1 times negative 15, and it has to equal our B value, which is 2. Okay, so 1 times negative 15 is negative 15. So the factors of negative 15 have to add up to be 2. All right, so negative 15. So negative 15 plus, times 1. So negative 15 plus 1. That's going to equal negative 14. That's not what I want. Negative, what's the next one? No, 2, I think 3. If I have 3, it would be 5, negative 5 times 3. That will give me negative 15. So negative 5 plus 3 is equal to negative, hey, negative 2. That's pretty close to 2. If you recall, doesn't matter which one of these negatives. So whenever you see that, what we're going to do is we're going to switch these up. We're going to go negative 3 times positive 5. And then we'll take this, negative 3 plus 5. And guess what? That equals positive 2. So these are our factors that we're going to equal 2. So what we can do is we can write this out again. We have z squared, all right, plus, now we're going to take our factors, negative 3, and I'll erase that. So we have negative 3, it's going to be our one factor, times x, and then the 5, it's going to be plus 5 times x, and that's going to have negative 15 right there. All right, so the az squared, and this is going to be the same, and we have right here. All right, oh, why do I have x? It should be z. These are z's. I'm not using x. Bah humbug. I'm so sorry. All right, confusing everybody out there, including myself. Not cool, not cool at all. All right, so now we take our grouping. Now we're going to group our two expressions together. All right, so we have this right here. We can factor out a z, and then I have z minus 3. I feel like I'm French. Z minus 3, and then we're going to take our 5. We have 5z minus 15. Factor out the 5. And what we have then is z minus 3. Hey, they are the same. Yep, yep. Voulez-vous français? And now we're going to factor out z minus 3 out of each one of these, because that's the common thing between them. What do we have left over then is z plus 5. And that, my friends, is factoring using the AC method. I'm going to do one more because this is so awesome. One more. All right. N squared minus 64. What? Okay. This one, you might remember, is going to be the difference in squares, but we'll use the AC method to help us figure this one out. What we have here is, remember, an squared plus bn plus c. That's essentially what we're looking for. Now, you notice that we don't have an n term. So guess what? When we're using the AC method, our b term is 0. All right, so we're looking for what are the factors of 64. All right, so we have 1 times negative 64. And what we have is negative 64 is going to be our answer. All right, so what are the factors of negative 64 that will give us 0? Usually when you have this, you're looking for perfect squares. So we could go negative 64 times 1. And wait, guess what you get? Negative 64 plus 1. Well, that definitely doesn't equal 0. All right, that doesn't equal 0. I'm not going to write it down anymore. So that, oh, okay, well, negative 63. All right, and then we go to the next one. Well, negative 8 times 8, right? Negative 8 plus 8. Hey, that equals 0. That's what we're talking about. These are our factors. So over here, we can write n squared. We have minus 8n plus 8n minus 64. All right, you can then group these just like we did all the other ones we did. We have n times n minus 8. And then we can factor out what are the two things. One of these things just like the other. What can we factor out? 8. Factor a common number or factors out here. We get negative 8. Notice once again, same. So we have factor out this and this, n minus 8. What do we have left over? N plus 8. And that is what we call the difference of squares, but also how we can use, all right, the AC method to even factor these types. All right, so we did some easy ones using the AC method. We did some hard ones using the AC method in my previous tutorials. I'm going to do 3 more in the next lesson, but I hope this gets you started, and I hope this helps you how to factor quadratics, binomials, trinomials, and I hope this serves you well. All right, good luck and God bless in the rest of your problems.